Okay, so yeah, like Steve said, I've been working on the LinuxKit portion of this project. We have everything working on Ubuntu Linux, and we've been doing the LinuxKit prototype as well here. The comparisons between the two are obvious. We see all the benefits of LinuxKit, the smaller image size, the faster provision times, the built-in security that you get, the reduced attack vector. Let's have a look at our LinuxKit swarm node architecture here. The bottom two layers, the kernel layer and the init layer, these are the same layers that all of the LinuxKit VMs use. On the on-boot layer, these are the containers that we run on boot. We have a special container for mounting persistent storage, which I'll talk about in a minute. And then the metadata container, since we're running this in the cloud, we need a way to network everything and get our DNS all set up, and then also pass in a couple of user data scripts. All of our services containers, since this is a Docker Swarm node, the Docker container is obviously the star of the show. The rest of the containers up there are either there to support the Docker container or to provide something for either usability or serviceability. We'll talk about a couple of scenarios here quick that we ran into. When we're bootstrapping the Ubuntu VM, obviously when we pass in a user data script, we just run it and it's completely sequential. On LinuxKit, we have both the NFS and Docker running in service containers. And the Docker container relies on the NFS container to be completely up and running and everything to be mounted before it can truly start. So we have to cover some synchronization there and make sure that that is working. And then the other things that we've added, we can talk about. Containers that we've added for serviceability purposes. We need, it's going to be an enterprise solution, so we need to keep system and audit logs around. We need to keep diagnostic information around. And obviously the administrator of the VM needs to have command line access in some form to be able to access the machine. Like Steve said, everything, we start by provisioning the VM through Terraform. And as part of that Terraform provision process, we pass in a user data script, a user metadata that basically does some initial configuration. On Ubuntu, we run that script just up front through the cloud init process. On LinuxKit, we actually take that script during the metadata on boot container and we drop it into a common location that both our Docker and our NFS containers will have access to. The metadata container also takes care of all our initial configuration. Let's see here. Once that is in place, once the on-boot containers are finished running, they die. So we can't do the initial configuration. We can't do all the configuration for the service containers up front when the two service containers depend on each other. So what we've done is we've added different sections to our initialization script, and we just use scoping variables to determine which piece of the initialization script needs to be run in the different service containers, and then each of those service containers will run their portion of that script. Since we only have one script we can pass in, we have to do this. And then so this is a diagram displaying the synchronization locking that we do. We basically drop a lock file into place if we've detected that we're going to use NFS, and on any multi-manager situation we're going to use NFS. We drop a lock file into place, and then the NFS container has to finish running and finish mounting the NFS storage and have everything up and running before the Docker container will continue. The other pieces that we've added to the LinuxKit VM, we add a handful of things for serviceability. We need to keep around logging and auditing information. Since LinuxKit is immutable by default, you'll lose a lot of this information on reboot. So we mount a persistent storage volume to var log so that we can keep all of our log files around on reboot. So if the VM ever goes down, We'll have those for diagnostic purposes. This also helps, for anyone who needs to do any kind of auditing information. Those like the SSH log files, those will all be around. We've got two different access points, two different access containers. The public access container for the administrative user would be the SSH container. That's how they would get in and view the machine and run Docker commands on the machine. And then we'll also have a Getty container, a console container. Through our cloud, you can VPN into the cloud, and then you can get console access. So we leave both those on the VM. And then finally, we have one of the things we've run into in the past is every once in a while an external dependency will go down due to a DNS failure. So we've added a DNS mask service so that we can do host overrides. Every once in a while you need to supply IP addresses in place of the host names. And on LinuxKit, everything is immutable, so you can't actually update the etc host file. So this provides us a method to do that. I'm running very low on time here, but I was going to go. I have the other neat little bit here. This is my YAML file. Can't see it. Can't see it. Yes, you can see it. This is my YAML file. The other thing I do, I add a build number, a build ID. When I'm doing development work on this, I like to have the GitHub commit ID of the top commit, hard coded into the VM so that I can see where I was at when I built that VM. So let's go to a really brief demo here. I have a script that builds everything, and basically builds all the containers that I run on the LinuxKit VM, and then builds the LinuxKit VM. That script takes, and then that script also deploys it to our cloud. It uploads it to the cloud, imports it as an image, and then deploys it, and then runs some tests against it. That process takes a while, so I've run it over here. As you can see, there are a few successful tests here, checking to make sure that all the containers are up and everything. And then we will go take a quick, brief look here. I've got a 3-manage or 3-worker swarm deployed. If I do a Docker node ls, you can see that it's a 3-manage or 3-worker node. We are most definitely running on LinuxKit. I can see I've got my SSH container mounted to the container backend so that I can actually see the containers. This is for diagnostic purposes more than anything. We might remove this before the end here. And we can see our InfraKit containers running. So I guess this kind of takes us full circle. This is a 3-manage or 3-worker swarm deployed to the IBM cloud that is backed by LinuxKit and managed by InfraKit. That's all. Close enough. Oops.
Right, well, yeah, you just got a sneak preview of some of the things that have been going on with LinuxKit, which is really great to see that. It's been 6 months since we open sourced LinuxKit at DockerCon, and there's in Austin, and there's been a huge amount that happened. If you're not familiar with LinuxKit at all, and it's your first time you've seen it, because that's great. It's basically a toolkit for building secure, portable, lean operating systems. It is based on containerd. Everything runs as a container. It's lightweight, fully customizable, and you can build LinuxKit images just in a couple of minutes in your CI pipeline, which is a really important part of modern ops, and it's something that's really unique about LinuxKit. We've had loads and loads of people interested. This is probably out of date already. I only did these a few days ago, but we've had 75 contributors. We've got an external maintainer, Avi, who was here a few days ago, but unfortunately couldn't make it today. Most of the contributors are not Docker people. They're you in the broader community, and we've had thousands of commits since DockerCon, and the community's added support, for loads of platforms. Linux containers on Windows, there was a talk about at DockerCon, which is really exciting. We've been working with the team there really heavily. Azure support, OpenStack support, VMware and vCenter support, Packet.NET, Bare Metal, Cloud, Vultr, IBM Bluemix, as you just saw, Raspberry Pi, and we've made big improvements to the other platforms that we support, so KVM, HyperKit, Hyper-V, Google Cloud. There's also been loads and loads and loads and loads of smaller improvements that people have come. We've added TPM support, support for clean shutdown. We've been everything can run totally immutably, so we can boot from CD-ROM images, which is really useful. We've been updating the kernel. We're supporting, particularly for the LCAL work, we've been doing a lot of testing with 4.12, 4.13 kernels. Namespace sharing to do complicated network setups with system containers, which is really cool. Lots of improvements. We've rewritten a lot of stuff in Go, so it's much more maintainable. Updated everything to runtime spec 1.0 and full OCO support for that, and also we've been testing all the betas of Containerd as they come out, and so it's really, really kind of helped. We're looking to do a stable release once Containerd 1.0 is out in a few weeks, which is really cool. The Docker desktop editions, the Kubernetes demo you saw at DockerCon was all based on LinuxKit, and those are also rolling out to all our production our use cases, the desktop cases. I've been using the internal one for months. It's been very stable. And then really we want to get towards really supporting people in production use cases. So testing CI releases, stable releases, and we're really keen for you to talk about your production use case. If you want to talk about the next DockerCon or before that at one of the next Maybe summits or whatever, please come and talk to me, because we know we've got lots of people who are starting to put stuff into production. I heard loads of stories at DockerCon, and we're really excited about this, and we want to share those stories with other people.
Great. Hi, everyone. My name is Riyaz. I work on the Docker security team, also maintainer of LinuxKit with Justin. One thing we've been doing with LinuxKit that's very exciting with the community is we've had a special interest group that we've been running and ran every other week for our first few months. And really the motivation here was to understand what kind of interesting security projects there are out in the broader ecosystem, upstream Linux, across enterprise, other corporations, and really understand if we could help in LinuxKit make it easier to build and test and socialize these projects, and maybe even include it in LinuxKit. So I'd like to give you a flavor of some of the deep dives we've had. We've walked through multiple projects and had great sessions with these project maintainers. All of the videos, by the way, are open on YouTube for you to watch at your pleasure, as well as meeting notes are in the open on the LinuxKit repo. A few that I'd like to just highlight are we had an excellent presentation from Jason Donenfeld, who maintains WireGuard, which is a very lightweight, modern VPN that basically is based off of the noise protocol. And WireGuard is actually quite nice in LinuxKit. It's quite easy to set up to the point where we've actually included it in our kernel and our users' packages. So you can use it today in LinuxKit when you boot the base examples. We're also generally interested in type-safe system daemons, reducing classes of attacks by having daemons such as DHCP, written type-safe languages. We've been working with Mikhail Salion, who maintains the Landlock Linux security module. So if you're familiar with SE Linux and AppArmor, Landlock is a Linux security module like those two, but leverages extended Berkeley packet filters, which is a newer kernel feature with which you can make more robust decisions in your Linux security module. So I'm very excited about that. A project that goes hand in hand with Landlock is Memorizer. Nathan Dattenhan is the maintainer of Memorizer, which is a deep kernel logging and auditing tool. So you can imagine the output of Memorizer, looking into kernel memory allocations and other memory allocations, feeding robust rules into landlocks so you can secure your system. And last but not least, we also had a great deep dive from Nigel from HPE on the okernel project, which the goal of the okernel project is to separate the kernel into different privilege levels. So you can imagine having outer kernels, multiple outer kernels with grouped containers or single containers that share a very hyper-privileged inner kernel instead of the current architecture we have today. So going forward, if you have interesting projects, please let us know. We'd love to hear about them. We'd love to meet and talk about them. We also have a number of contributors directly contributing to upstream Linux kernel hardening efforts. So if you're familiar with the XPFO page mapping, as well as eBPF hardening, and working on figuring out how to namespace IMA. So if you went to Tycho Anderson's talk earlier this week at DockerCon, he has a number of other areas that he's been looking at in particular. So please tell us if you're interested in upstream Linux security and love to talk more about how we can test it out in LinuxKit and collaborate. So with that.
We made this intro really, really brief because we've had so many people, external people who want to come and talk, and their talks were much more interesting than ours anyway. So first I want to introduce Ilya from Weave. Ilya worked with LinuxKit since before we actually launched it publicly to help us out with Kubernetes support, because we knew that was going to be one of the really important things in LinuxKit. And so thanks very much. And,
Thank you. Thank you. It's been a pleasure to put the mic on. Thanks very much. Is the mic on now? Yeah? Great. Good morning, everyone. Hope you enjoyed DockerCon. So, yeah, I'd like to talk about what does LinuxKit mean to me? Why do I care, and perhaps why should you care about it? Because, I mean, we've seen a few demos. We've seen the Kubernetes demo. That's the work I contributed to. Yeah, but I just kind of wanted to cover some of the personal perspective as such, really. So, so yeah, well, I thought also like to do a thing like where I'd compare one thing to another, and then I realized that would take a lot of time. So if I were to compare different immutable OS patterns, different implementations, that would just take too much time. I wanted to show some horrible examples of stuff that I did in the past. That wouldn't fit in today. I only got like 10 minutes or something. So, so yeah. Well, yeah, I mean, to me, LinuxKit is a much better way to do Linux for containers. That's it. A disclaimer, all I care to run on Linux is containers. So, all right. So, with that out of the way, I'd like to talk about the immutability pattern and kind of, you know, at least my personal understanding of it. Let me know if I'm completely wrong. So, the kind of broadly, immutability is mostly about security and reliability to me, right? So you make sure that nobody can tamper with anything in the root file system by mounting it read-only, perhaps. And you make sure that everything is on the file system, nothing is downloaded at runtime, so that it boots reliably. Hopefully your boot time will be the same each time. Okay? Also, there's this boundary of immutability that you go and define, and that's kind of relative all the time, right? You go define that, and usually in terms of like path that would be read-only on your file system. Because in Unix everything is a file, so if we define immutability around files, that's just about everything, right? Supposedly. And you know, there are some of the examples, like for instance, Chorus does immutability, right? It's like a immutable pattern of sorts, and the USR directory is mounted read-only. Most of other directories are mounted read-only, except for etc and temp, right? But actually, the disk is mutable because they ship updates to partitions in turns. So they update one partition and then reboot into that. Well, they don't reboot, but use kexec, but that's details, right? But like the disk is mutable. Okay, well, that's the thing. And in Atomic, as far as I remember, do correct me if I'm wrong, but in Atomic, you kind of like, they don't really talk about immutability, but the way that new packages are installed, that's somewhat immutable, right? That's sort of immutable-ish, it seems. But maybe I'm completely wrong. Maybe they actually mount things read-only. But I thought they didn't. So, and you could do like, you know, weak or strong immutability, right? You could enforce it very strongly, or you could just sort of be really relaxed about it and just sort of treat things in an immutable way, but don't really enforce it by mounting file system read-only. So perhaps you want to be able to log into a system and install some package that would allow you to debug things in emergency type situation without having to remount things, because remounting is kind of complicated. And yeah, so but you wouldn't install updates on a running system or anything like that. You just bring up a new box, but you don't mount anything read-only. That's also possible for some folks, right? So do we have more theory here? Yeah. So runtime downloads and config are things that can be easily overlooked. I've done a lot of horrible things with that in the past, using like CoreOS and systemd and like downloading Kubernetes binaries, and then I thought, oh, Docker is a much better way of downloading things, so do Docker run. And yeah, so that's been fun. But like it's easy to overlook that. Oh, I'm just going to download this little script, right? That's going to work, right? Downloading thing from GitHub should work most of the time, or whatever, a gist or whatever, right? And it's version control, right? Yeah, so it's like I'll pin the revision of that, and that's cool, right? But it's yeah, it's easy to overlook what sort of damage you can cause with that. So LinuxKit. Well, in my opinion, LinuxKit enforces the boundary pretty strongly. It's essentially most of the things are read-only except for temp and varlib docker, right? And it's definitely oriented towards running containers. There isn't like a direct way of just starting a process from a configuration file. And yeah, it's all about containers. That's great. That's all I care about. I said that earlier, right? And most of the critical components with LinuxKit are going to be in your image. You're not going to download anything or configure anything. All the critical config and all the critical components and their config would be already in the image. And if it's not for some packages, that's just a matter of time until we fix that. So, and I think an important thing with LinuxKit is that it's very testable. It's got a framework that we've seen in use earlier in the previous demo. And yeah, you can write like unit tests for each of the packages and make sure they contain the right files. You can, I don't know, can make sure that they all x86 executables or whatever, and they have certain size or whatnot. And you can Docker run things and test things manually that way, and then write a little unit test, whatever. Yeah, like I mean, because it's kind of composable and decomposable at the same time, so you can unit test. Well, with having said all that, why should I care, right? A lot of people ask me that. So it's like, said, well, I wanted to make sure that Kubernetes user experience on desktop was great. And the best thing I've seen so far is Docker for Mac and Docker for Windows. And I loved it. I've been using it since it came out. And I've been using the Edge version. It doesn't crash, right? And, you know, then like I loved working with Justin and David and others in Docker team in Cambridge. And I thought, well, I'll just help them out and see what we can put out. So we've seen a demo, and it all works. And you know, but then I talked to my friends about LinuxKit, and they're like, what LinuxKit has to do with that anyway? I think first of all, with an immutable approach here, you get greater user experience. As you think about that for a moment. Essentially, what you get is, as a user, you download updates as ISOs, right? You download the entire system. You don't get packages installed within a running system. And what that gives you is that if some users happen to tweak config or whatever, or install some weird package that wasn't expected, when they get updates from upstream, there can be breakages, right? So the immutable approach here fixes that problem. You just always get new ISO, you get the entire system, and that's it. You may have some state still, because we do preserve certain things on upgrades. However, for the system and the configuration, like the system binaries and configuration files, that will come with an update, right? It's an entire sealed ISO. And yeah, you essentially get a pre-baked, fully tested artifact, and not some bits of things that then get put together with other bits of things that may have changed over time or been overlooked by somebody. So in your local setup is identical to what you'd use in production. So why should you be doing like, you know, why should you have like a mutable system in a local setup and an immutable system in production? Oh, just because I want to hack on it, right? Whatever. That's not a good idea, I don't think. And more broadly, you do want to have identical type of configuration, identical shape of configuration in production and in a local setup or whatever other environment you have. And that's it. Hopefully this makes sense. Thank you very much. Thank you. It's been a pleasure.
All right. Yeah, so thanks, Ilya. Well, we changed the program slightly. We're going to have Andrew do the demo on ARM, and then we'll take a break, so at 45.
Sure. Oh, no, I need
Oh, and Ilya, that slide you had with all I care to run on Linux is containers, I want a T-shirt with that.
Oh, cool.
no, that's fine. Thanks. Morning. So I'm Andy Wafaa. I work for ARM, and for those that don't know who ARM are, we're a CPU IP company. If you've got a cell phone, tablet, there's a pretty good chance you have one of our processor IPs in there. So I'm standing in actually for one of our engineers who couldn't make it, unfortunately, a chap called Dennis Chen. He's been working quite heavily upstream with the likes of Rolf, etc., on getting ARM support into LinuxKit. So I've got a few slides that I'll quickly rattle through, and then I'll get on to the quick demo. So just doing a quick overview of ARM, just for those that aren't aware, and why ARM64 is relevant to LinuxKit and containers in general, and then go through some of the status. So, as I mentioned, we're in cell phones, we're in smaller devices, quite well known, but we're also working up the stack, going through in the network space and also into server space, going into cloud, etc. The evolution of the ARM processor has been driven by the evolution within the enterprise and within usage in general. So when I was young, you had single monolithic machines, and then as I was growing up, things were going more cloudy, and now with all the microservices and containers, I've turned into a grumpy old person. Our architecture's evolved over time, 24 years. I think first production ARM processor was back in '83 in the BBC Micro, and we've evolved as gone through and tried to ensure that we've had backwards compatibility with at least certain aspects of previous generations. We're currently on the 8th generation of our architecture, which introduced 64-bit support, and also at the same time that introduced native virtualization, hardware virtualization extensions, and we're continuing to evolve the architecture as we move forward. One of the differences that ARM processors have with some of the other things out there is that we are what's known as a system on chip. It's not just a CPU, it's the CPU plus a lot of the peripherals. And one of the key areas that we work on is on the interconnect. So we've got interconnect for the actual silicon peripherals, but we've also got interconnect technologies for scaling up as well as scaling out depending on what your use case is. Multiple standards to ensure that it's much more portable for people in their code. It's simple from a software perspective. You don't have to worry about any little nuances like you may have had to in the past. So we've got standards for interconnecting with the various areas, and also with C6 there enables much better leveraging of things like ASICs, FPGAs, etc. Whilst it's a single architecture, it's not from a single vendor, so you don't have, sorry, quick marketing disclaimer here. There's no single vendor lock-in, so we have got an ecosystem of hardware vendors out there providing different solutions for you, so that means that from a purchasing perspective, you can purchase a system from Qualcomm and run your software on that, but you decide to then buy systems from Cavium, that software just moves across. You don't care who the silicon vendor is. So onto some of the LinuxKit pieces. There were several challenges when we started working on the project. A lot of the code was hard-coded for x86. So there was a lot of cleanup that we had to try and work with upstream to ensure that it was a single code base that could support ARM as well. Fantastic work that Phil and crew did with multi-arch support was crucial. And some of the underlying packages required from Alpine were missing, so we had to work with the Alpine community and get some of those on there. Some packages still won't work on ARM64 at the moment, things like Gummy Boot, etc. But we are working with upstream to get things in the right place. So work started really in April this year. We managed to get a fork working in July, and then working with the upstream team, we managed to get a lot of that merged in August this year. So it was effectively 13 patches to get merged upstream, and there was quite a bit of refactoring needed to get things in the right place. This slide is actually a little bit out of date because that one patch that was under review has now been merged. So I'm actually going to demo the ISO EFI generation aspects here in a second. One of the outstanding issues is external firmware, secure console, as well as some networking aspects, but they shouldn't be too big. So our next steps really are looking at the security aspects of things, ensuring content trust builds there, secure boot, Grub2. For some of our enterprise customers do have a requirement for Grub. We want to look at optimization aspects as we move forward, both from a size and also from a speed perspective. And also we'll be looking at increasing our contributions with the community, both LinuxKit, Alpine, etc. So with the boring piece out of the way, let me... Right, so I'm on a server hosted by Packet.net, 96 cores, as you can see there, just to show that it's not Raspberry Pi. So to build LinuxKit, obviously you've got your YAML file, as would be expected. Nothing unusual there. It's fairly routine. I just need to... So I always forget. So what I'm going to do here, actually let me try and bring that down a bit. It's obviously running LinuxKit, calling QEMU, and we're going to boot the UEFI using and providing the actual firmware for QEMU to use, and telling it to create the ISO from there. So, typical. Bear with me 2 seconds. Yeah. There we go. So. You need to update your CA. Sorry? Yep. So I've also got. Apparently so. Come on. I'm an honest person. It did build fast like this yesterday, I promise. There we go. Right. So we now have the ISO created, and move out of the way. We can run it. Or not. Ah. And if you can see at the bottom, you can see the relevant containers. That's it.